Good morning. Today is the first lesson of Module 7. We're going to start with Lesson 1. Our standard that we're going to be working on is 8NS1, and it's all about identifying rational and irrational numbers and decimals and fractions. So we're going to be getting into that eventually. Today we're going to be working strictly with right triangles. It's kind of like a basis lesson for this work. The objective is that by the end of the lesson you'll be able to find the missing length of a right triangle by applying the Pythagorean theorem. You'll know you're successful when you can identify the A, B, and C sides of a right triangle and create an equation to solve for your missing side length using that theorem. You'll be using your knowledge of exponents and radicals to solve. So that's what we're going to do today. You can go ahead and look at this triangle down in the corner. Our equations are going to be like this. We're going to identify A, B, and C. And we're going to use that equation at the bottom, which is Pythagorean's theorem, to solve for our missing side lengths. All right, we're just going to build some background knowledge here. So what I write down, I do want you to write down. So the first little box, it says, when dealing with exponents, we have a base and a power. So the power in this case is 4, and the base in this case is 5. And what that means is we're going to be taking our base, so our number 5, and we will be multiplying it by itself 4 times. That's what this actually means to do mathematically. But it saves us some space, right? It's a lot simpler than saying 5 times 5 times 5 times 5, right? When we square a number, that means that we are raising it to the second power. Okay? So this 3 is being raised to the second power, so this means when we multiply it out, 3 times itself twice, which equals 9. Okay? When we cube a number, that means that we're raising it to the third power. So you can see that this 3 is now being cubed, which would mean we would be doing 3 times 3 times 3. This is very different than 3 times 3. So a lot of people get that mixed up. But we have to do it 3 times. So this answer is not going to be 9. 3 plus 3 plus 3 is 9. But 3 times 3 is 9, times another 3 is 27. Okay? Moving on to a little bit of new learning, it says the opposite of squaring a number is finding the square root of a number. It's basically asking us to find what that number is being multiplied, what number is being multiplied by itself to get that number within the radical symbol. So this is a radical symbol. And it's asking us, this number inside this 9, what number multiplied by itself equals 9? So we can kind of think about this on our own. It's kind of like a guess and check method sometimes, but what times what equals 9? Well, 3 times 3 equals 9. So what does this equal? What does x equal? X would equal 3. So the square root of 9 equals 3, because 3 times 3 equals 9. So if we're trying to find what squared equals that 9 in the radical sign, it's going to be 3. And again, down below it says we can find, or we can show what we want to find the square root of by using a radical symbol. So maybe if I did the square root of 100. Well, what times itself equals 100? 10 times itself, right? 10 times 10 equals 100. So the square root of 100 equals 10. So this is just some background knowledge before we move into our work today. Just make sure you have the stuff down and we can reference it throughout our lesson. All right, so this is lesson 1. Pythagorean's theorem is a squared plus b squared equals c squared. You will see that up top when I wrote this. When you type out the numbers being squared, you can't make that little 2 up in the right-hand corner without doing some row manipulation. So the easy way to type this out is to put this little arrow sign and then just write it 2. So that says a squared. But I'll rewrite it real quick so that you can see it a little bit different. A squared plus b squared equals c squared. So this is Pythagorean's theorem for a right triangle. So meaning you have to have a right angle for this theorem, this formula, to work. The first thing you want to do is identify A, B, and C. So you have three sides to your triangle. So one of these sides is going to be A, one of these sides is going to be B, and one of these sides is going to be a C. A and B, these are your bases. This means they are flat, right? If you're laying something down on its base, it has to be completely flat. So there's going to be two flat sides, okay? And then C, this is going to be your hypotenuse. So this is your slanted line. And this is your hypotenuse. So really get used to using that word hypotenuse. So in this case, I can see that the slant is this line right here. So this side is going to be my C side. And then the other two sides are my bases, right? They're the straight lines. And it doesn't matter which one you call A and which one you call B. Just know that one of these is an A, one of these is a B. All right? So that's the first step. The second step is to set up our equation. Okay, so usually they're going to give you two numbers. So you can see that they give us this 5 and they give us this 13. And so what we're going to be trying to find is what does this side equal? Because that's what we don't know. So we're going to use our formula and set up what we know. So we have a squared plus b squared equals c squared, and we're going to plug in our variables. Do we know what a is? No, we don't know what a is, so this stays the same. Do we know what b is? Yeah, b is 5. This becomes 5 squared. And do we know what c is? Yes, it's 13, so that becomes 13 squared. Okay, from there we can solve, and we're just going to draw a line through our sign. So what we are trying to get completely by itself is this a. There's a lot going on, but the first thing we want to do, we have to follow our order of operations, is parentheses. There's no parentheses, so the next thing we do exponents. So we're going to do our exponents. We're going to simplify these two numbers. Well, 5 squared is the same as saying 5 times 5. That equals 25. So this becomes a 25. 13 squared is the same as saying 13 times 13. And if you do that in your calculator, it's 169. Everything else stayed the same. Still trying to get that a by itself. Right now there's a plus 25 beside it, so I'm going to do the opposite of plus 25. I'm going to get rid of this and subtract 25 from both sides. Over here it cancels, and I'm left with a squared equals 169 minus 25 in your calculator is 144. So what this means is that a times itself equals 144. So what number times itself equals 144? Well, we still got to get a completely by itself. Right now it's being squared. So the opposite of squaring a number is finding the square root of a number. And we're going to do that on both sides. This is your new learning. Over here, this radical sign cancels this square, and we're left with a equals. And let's think about the number 144. What times itself equals 144? Well, I know 10 times 10 equals 100. 11 times 11, 121. 12 times 12, 144. So, what times itself equals 144? What's the square root? 12. So the third thing we just did was solve. And our answer is that side A is 12, what is this, centimeters? Centimeters. All right, make sure you have this down, and we will move on to our second practice set. All right, first step is to identify our bases and our hypotenuse. I always do the hypotenuse first because it's easier to see. There is my hypotenuse, so that is my C, that's my slant. And then I just have A and B. So this time I'm going to be solving for my hypotenuse. I don't know that length. So I'm just going to plug in my equation and solve. I have a squared plus b squared equals c squared. This is my formula. Do I know what a is? Yeah, a is a 4, so this becomes 4 squared. Do I know what b is? Yes, this is a 9, so this becomes 9 squared equals c squared. I don't know what that c is yet. From there I'm going to solve. I'm trying to get c by itself. It's already pretty much by itself, so what I'm going to do is I'm going to do my exponents on this side and combine these like terms. So 4 squared This is the same as saying 4 times 4, which is 16. So this becomes 16 plus 9 squared. It's the same as saying 9 times 9, which is 81. And that equals c squared. Okay. From there, I'm going to add these two numbers up, 16 plus 81. I'm just going to do it in my calculator really quickly. I get 97. So 97 equals c squared. We're trying to get the c completely by itself. Right now it's being squared, so we have to do the opposite. The opposite of doing the square of something is taking the square root. So I'm going to take the square root of both sides. Over here, this just becomes the square root of 97. Over here, these cancel, and I'm just left with c. So my answer here is that c equals the square root of 97. All right, hopefully it makes sense to you. The only real new part here is the formula and the radical sign, finding the square root of something. All right, make sure you got it down, and we'll move on to the next slide. One thing I do want to say here is that I do know that c is probably going to be close to around 10, because the square root of 100 is 10, and this is the square root of 97, so it's pretty close. So we'll get into work tomorrow learning about how to estimate what that number is a little bit more accurately. All right, the first thing you want to do is identify your A, your B, and your C. Remember, your C is just always your slant. It doesn't matter if you mix up A and B, okay? And then we're going to create our equation. A squared plus B squared equals C squared. In this case, do we know our A? I have it as 8. Our B, I have it as 3. And our C is what we are missing, what we're trying to find. So we're going to solve this. First step is to do our exponents. So 8 squared is the same as saying 8 times 8, and that is 64. And 3 squared is the same as saying 3 times 3, which is 9. So this becomes 64 plus 9 equals c squared. Okay? From there, I'm just going to add up 64 and 9, simplify this a little bit more. 64 plus 9 is 73. This becomes 73 equals c squared. To get c completely by itself, we have to get rid of this squared sign. So to do that, we have to take the square root of this number, and we do it to both sides. Over here, the radical cancels this too, or the square, and we're left with c. Square root of 73. 73, we would have to find the square root of that. So essentially it's saying what times what, or what times itself equals 73. Well, we know that 8 times 8 is 64. If we did 9 times 9, that would be too much. That would be 81. So we don't have a perfect square because there's no number between 8 and 9, right? So we're just going to leave this in radical form. Again, tomorrow and throughout the week, we will learn how to simplify this a little bit more and guess a little bit more on this. But our answer is c equals the square root of 73 centimeters. And we're going to leave our answer like that. The last thing I wanted to say here is that c, this is between 8 and 9. So it's about 8 centimeters long. So it's 8 to 9 centimeters long, because we know it's in between 64 and 81 for our square root. So that's why we're going to guess that. but we don't have to do that yet. We'll do that tomorrow. All right, let's review your new learning for today before you get into your practice. A triangle has two bases and one hypotenuse. Here are the bases here. They're the flat lines. And here is the hypotenuse here. It's the slant. The bases are represented with the variables a and b. And I'll do that real quick. So this would be an a, this would be a b. You could switch them, doesn't matter. And our slant, our hypotenuse, is represented with the variable c. Okay? To find the missing length of one side of this triangle, which we're missing b right now, we use Pythagorean's theorem, which is a squared plus b squared equals c squared. And we just plug in the numbers that we do know. We know that a is 5, we know that c is 13, to find our missing length. So we did this earlier, so this becomes 5 squared plus b squared, because we still don't know b, equals 13 squared. Okay, from there you can solve, and I'll do that really quickly. And we did this on our first example, but I got b by itself, and I was able to find that b equals 12 centimeters. Okay? If we do not get a perfect root, so this one was 144, so that's a perfect square root. If we got something like 150, no whole number is going to equal 150. So we would just leave our answer in this radical format. Just say, okay, well, our answer is the square root of 150. Okay? All right, that's our new learning for today. We're going to move on and do some practice. All right, I'm going to start you off a little bit here and then have you solve it on your own. First thing you need to do is identify A, B, and C. I know that my slant is C, so my slant is 11. I know that my two bases are the flat sides, so I have this A and this B. Okay, from there we're going to fill in our equation. So A was a 6, so this becomes 6 squared. B, we don't have it, so this stays b squared. And C was an 11, so this becomes 11 squared. All right, I want you to go ahead and solve this now. Try to get b completely by itself. Start with your exponents, then isolate your variable. All right, so here's the work that I showed for this question and the answer that I got. The first thing I did was I took 36 away from both sides, and I got b squared equals 85. From there, I tried to get rid of the b squared. I tried to get rid of the squared sign. So I took the square root, and I did it on both sides. On one side, it canceled the square root. Sign canceled the square, and I was just left with b. And on the other side, I couldn't find a perfect square for 85. I know 81, that would be 9 times 9, but it's pretty close to 9, but it's not exactly 9. So my answer was b equals the square root of 85 centimeters, which is close to 9. All right, make sure you have your answer, and we will move on to the next one. All right, for this next one, I want you to go ahead and I want you to identify A, B, and C and set up your equation accordingly, and we'll check in about 30 seconds, okay? Find your A, find your B, find your C. All right, so these are my bases here, 6 and 10, and my hypotenuse is what I don't know. So this was what I'm going to be trying to find today. Right? So I know that A is a 6, so this becomes 6 squared. B is a 10, so this becomes 10 squared. And C is what we don't know. That's what we're trying to find. Okay? I want you to go ahead and solve this. Get C completely by itself and tell me, what does that hypotenuse equal in terms of inches? All right? Take a second to do it. All right, the first thing I wanted to do was simplify my exponents. So I'm going to do 6 squared and 10 squared, find out what those actually equal. 6 times 6 is 36. 10 times 10 is 100. Okay. From there, I'm going to combine those two numbers together to make this side a little bit simpler. 36 plus 100 is 136. All right, now I'm trying to get c by itself. Right now it's being squared, so I have to undo this squared. What I'm going to do is I'm going to take the square root. So the square root of c and the square root of 136. Over here, the square root of c, the square root of c squared cancels, and I'm left with c equals, and I'm going to think about the square root of 136. Well, I know 10 times 10 is 100. 11 times 11 is 121, and 12 times 12 is 144. So that was a little bit too much. So it's not going to be perfect square because I just have all my whole numbers right there, 10, 11, and 12. So it's going to be in between these two numbers, right? In between 121 and 44 is 136. So it's going to be around maybe 11 and a half, maybe a little bit less, but it's going to be between 11 and 12. But we don't have the correct answer. We don't have a, we don't have the correct answer. We just don't have our simplified answer. So we're going to have to leave it in a radical sign. So the side length of c is the root of 136 inches. Okay, which we know is around 11 to 12. All right, make sure you have it down. Ask me questions if you have any questions in the chat, and we're going to move on to exercise number 3. All right, exercise number 3, I want you guys to do with your breakout groups right now. So go ahead and in your groups, I want you to fill in your equation with your A, B, and C, and I want you to solve and tell me what does that missing length equal, okay? I'm going to send you there for 3 minutes to do this, so please make sure you're on task. You need to be working together. You're not silent. You're actually getting this done together and comparing your answers and agreeing on something, okay? All right, here's the work that I showed. Please check it with mine. The first thing I did was identified A, B, and C. I was finding for a side length right here, so you could have either said you were solving for A or you were solving for B, depending on what variable you put there. Right, when I did my math, I got it down to right here, and I'm going to start right here explaining. I got b squared equals 40, so I took the square root of both sides. Over here, the square root canceled the square, and I was just left with b. Over here, I could not find a perfect square for 40, so I know that 6 times 6 is 36, 7 times 7 is 49, so it's going to be in between these two numbers. So my answer I just left as the square root of 40, and then I put off to the side around 6 to 7. Okay, check your work before we move into our closure and exit ticket. All right, our closure for today is that to find the missing length of one side of a right triangle, we use Pythagorean's theorem. The theorem is a squared plus b squared equals c squared, and again you use these little up signs and a 2 to show squared when you're typing, because you can't really make that 2 a tiny one up top. We plug in whichever variables we know to solve for our missing variable, and we can leave our answer in radical format, so like our last one, if there's no perfect square root. Okay, let's move on to our exit ticket. All right, your exit ticket is exactly like the practice we did in class. I want you to identify A, B, and C, and I want you to solve for your missing side length. If it's a perfect square root, cool. Write it as a whole number. If it's not, use your radical sign. Leave it in radical format, okay? Take your time, show your work, do your best, please, and then move on to your lesson reflection in Google Classroom.